Economic dispatch solved problem 4. The fuel cost function for 3 thermal plant in dollar per hour are given by C1 equal to 500 plus 5.3 P1 plus 0.004 P1 square, C2 equal to 400 plus 5.5 P2 plus 0.006 P2 square, C3 equal to 200 plus 5.8 P3 plus 0.009 P3 square. And the limits are given for P1, P2 and P3, where P1, P2, P3 are in megawatt. The total load is 975 megawatt with the following generated limits are in megawatt. So find the optimal dispatch and the total cost in dollar per hour by iterative technique using a gradient method. Consider initial value of lambda equal to $6.0 per megawatt hour. So in this problem, the cost function is given, the limits are given, total demand is given, and the lambda value is given. We are going to solve this problem using gradient method. Solution. Step 1. Assume the initial value of lambda and determine the power generation. So here in the problem they have specified the lambda value as 6.0. We can take that value directly. So in some problem they will not mention this lambda value. So in such case we need to assume some initial value of lambda. So how to choose that lambda value? In the power generation formula, P1 equal to lambda minus B1 by 2A1. So in the numerator it is lambda minus B1. So in the cost function, this B1 is 5.3 here and B2 is 5.5 and B3 is 5.8. Greater than this values, we can select the lambda value. So in this problem, if the lambda is not given, then we can take greater than 5.8 as lambda. But in this problem, the lambda value is specified. So we can take directly the lambda value as 6.0. Now we can find the power generation. P1 equal to lambda minus B1 by 2A1. So substituting that lambda, 6.0 minus B1 is 5.3 divided by 2 into A1 is 0.004. So that gives you 87.50 megawatt. And for the second unit, P2 equal to lambda minus B2 by 2A2. So 6 minus 5.5 and A2 is 0.006. You'll be getting 41.667 megawatt. Similarly for the third unit, 6 minus 5.8 divided by 2 into 0.009, that gives you 11.111 megawatt. So now the total power generation, adding all the values P1 plus P2 plus P3, you will be getting 140.278 megawatt. But the demand given in the problem is 975 megawatt. So the error will be del P equal to demand minus generation. Demand is 975 minus generation. The total generation is 140.278. So the error value will be 834.722 megawatt. Now step 2, determine the change in lambda. So in the assumed lambda value, we calculated the power generation. The total power generation is very less than the demand. So we got the error. So now we are going to find the change in lambda value, del lambda. So del lambda, using this formula, del lambda equal to del P, the error, divided by summation of I equal to 1 to n, 1 by 2 AI. So 1 by 2 A1 plus 1 by 2 A2 plus 1 by 2 A3. And del P value, the error in the previous step we calculated 834.722 divided by 1 by 2 into A1 is 0.004, A2 is 0.006 and A3 is 0.009. So you will be getting 3.1632 as the change in lambda, del lambda. Now using this, in step 3, we can determine the new value of lambda. Lambda new equal to lambda old plus del lambda. Old value of lambda is the lambda given, that is 6.0, plus the del lambda 3.1632, that gives you 9.1632 as new value of lambda. So now using this new value of lambda, we are going to determine the power generation once again for the second iteration. So continue the process for second iteration. The new value of lambda is 9.1632. So for that, P1 equal to 9.1632 minus B1 divided by 2 into A1. So you'll be getting 482.9 megawatt. P2 is equal to 305.26 megawatt and P3 is equal to 186.844 megawatt. Now the total power generation will be 975 megawatt. So if you are adding all the 3 units power, you will be getting 975 megawatt. And the given value of demand is 975 megawatt. So the error will be del P equal to PD minus PG, 975 minus 975, that is equal to 0. So here the error is 0, and now we are going to check the generation limits. So that is the step 5, check generation limits. These are the generation value we got in the previous step, and this is a limit given in the problem. So by comparing this, P1 limit will be 200 to 450, but here the value is 482. So P1 violates the limit, and P2 is within the limit 305, and P3 also within the limit 100 to 225. So here it is 186. So it is within the limit. So P2 and P3 values are within the limits, but P1 value exceeds the upper limit. So P1 is greater than the upper value. So what we need to do? So we need to set this P1 is equal to the upper limit. The upper limit is nothing but 450. So P1 is equal to 450. So now the new value of generation is P1 equal to 450, P2 equal to the same value, and P3 is equal to the same value 186.844 megawatt. Now if you are adding all the three generation, you will be getting 942.104 megawatt, which is again less than the demand of 975 megawatt. So you will be getting a error. So demand minus generation, that gives you 32.896 as error. If you get an error, then we need to find out the new value of lambda. So for that, we need to find the change in lambda. Del lambda equal to del P divided by summation I equal to 1 to n 1 by 2 ai. So in this case, we are going to substitute only the second and third unit values, 1 by 2 a2 and 1 by 2 a3. No need of the first unit, since in the previous step we set the first unit generation value as 450. So there is no change in that. So leaving that, the remaining two units we need to consider the second unit and third unit. So del P is 32.896, the error we calculated in the previous step, divided by 1 by 2 into A2 plus 1 by 2 into A3. So that gives you 0.2368, and this is your del lambda. So using this del lambda, we are going to find the new value of lambda. So lambda new is equal to lambda old plus del lambda. Old value of lambda is the second iteration lambda, which is 9.1632. Don't substitute 6.0 here. 6.0 is the first iteration lambda. Now 9.1632 is the second iteration lambda. That is the old value now. Adding this with the del lambda, you will be getting the new value of lambda as 9.4. So now we are going to use this new value of lambda to find the power generation. So continue the process for third iteration. Lambda value is 9.4 and the P1 is fixed, that is 450 megawatt. P2 we need to find using this new value of lambda, that is 325 megawatt, and P3 is 200 megawatt. Now if you add all the three generation, the total power generation will be 975 megawatt. Now the demand given is 975 megawatt. So the error will be del P equal to PD minus PG. 975 minus 975 which will be equal to 0. So the error is 0 and P2 and P3 are within the limits. P1 is fixed with the 450 megawatt. Thus the optimal dispatch is P1 equal to 450 megawatt, P2 is 325 megawatt, and P3 is 200 megawatt. Now in the problem, they asked to find out the total cost of generation. So to find that, the total cost of generation CT is equal to C1 plus C2 plus C3. So simply add the cost function, substituting the optimal dispatch value P1 equal to 450, P2 equal to 325, and P3 equal to 200 megawatt. So 500 plus 5.3 into P1 450 and 0.004 P1 450 square. So similarly for P2 and P3, adding all those things, we will be getting the CT as $8236.26 per hour. So the total cost of generation will be $8236.25 per hour. So this is how we need to solve this problem using gradient method.